Integrated Science. This is Mr. B, and for this video we are jumping not only to a new chapter, we're jumping all the way to chapter 25, but it's also going to be a new unit. This unit is going to focus mostly on astronomy, which hopefully that word is not too new to you. We can talk about that more as we get going here. And this chapter is going to focus on the solar system. So for all of us listening and taking notes out there, you probably need to know what the name of this chapter was, just to make sure we're all paying attention. And the first section within this chapter is called Exploring the Solar System. So this is actually going to kind of start from our most ancient understandings of the solar system, and kind of what the first humans who really started to observe the sky and observe the stars and observe the things that are going on outside of Earth, what they saw and what their ideas were. And it kind of starts with one of our most ancient civilizations, the Mayan ruin of El Caracol, or if I'm pronouncing that correctly, I just looked it up, but now I can't remember. But it's also known as the observatory. It's located on the Yucatan Peninsula, which is in Mexico. And it is thought that the Mayans used this observatory for astronomical observations. So again, the Mayans, again, I'm not going to pretend like I'm an overly history major, but again, they're one of our most kind of prominent ancient civilizations there. And so this structure kind of shows that people have been exploring, or at least been curious about the solar system for a very long time. There were a couple of ideas that kind of were the more prominent ones for what our solar system actually was composed of, what its structure was, what it looked like. And those two different models for what the solar system are were called the geocentric versus the heliocentric model. These two, again, make sure you write both of those down as well. The geocentric model, in this Earth was stationary while objects in the sky moved around it. And then in the heliocentric model, Earth and the other planets revolved around the sun. How I might be able to remember those like geocentric there. Geography, you study the Earth, so in the geocentric model, Earth is in the center, and then centric literally just means center there. Helio, again, I can't remember Latin or Greek now, but helio means sun, so that is with the sun at the center. So the big portion of this video is going to be talking about who was in support of the geocentric model, how did we come up with that, and then the heliocentric model, who was in support of that. Hopefully, again, I'm not going to give away the ending yet, but hopefully we might know which one of these is correct. Hopefully that which one of those is at the center. So just kind of give us some background of where these two models came from. It says, ancient observers noticed that most objects in the sky seem to be in a state of slow but steady motion. Again, they look up, the sun and moon would appear to rise in the east and set in the west, which again is correct to an extent there, and that the stars kind of followed a pattern as they went across the sky. So they could make these observations. Again, to them it appeared the sun was moving, appeared the moon was moving. Again, it kind of appears that the stars, again, which might have been a little more, again, they were all in one place, but they kind of noticed that, again, they followed a pattern. So the ancient people, again, the first people who really started looking up into the skies to kind of ponder what else is out there, they concluded that Earth was stationary and that the sun, moon, and stars all moved around the Earth. And this kind of comes from I'm kind of doing some other research about this on my own, that people kind of like to think that we're at the center of things. So it would be just kind of make a lot of sense for the first people, again, with basically no technology whatsoever, to conclude, yes, well, we're here, we're the most important, we must be at the center of everything, and everything else must be revolving around us. So that's kind of, again, kind of another kind of where this geocentric model stemmed from. Again, they noticed that there were a few other bright starlight objects that would seem to wander slowly among the fixed patterns of stars. So again, the stars, they noticed, kind of looked like they were in the same spot. However, they saw brighter objects that kind of appeared to be stars. However, they were moving along within the patterns of the stars. And these objects were called planets. They got the name planets, which came from the Greek word for wanderers. So that's kind of the origin. Again, hopefully we've all heard of different planets that fall within our solar system. So that would probably be something important you need to write down there, that again, the Greek word for wanderers gives us the origin of planets. The ancients knew of 5 planets that can be seen with the unaided eye. They knew of Mercury, Venus, Mars, Jupiter, and Saturn, again, to go along well with the moon and the sun. So they could identify kind of 7 different total objects that were moving in the sky there. And again, big takeaway thing there. Again, they didn't really have any technology. They just kind of saw these things moving across the sky there. And again, just kind of supporting the idea that we were at the center of all of it. And then again, the geocentric model. So again, most ancient Greeks, which is where it kind of spawned from, thought that all the stars and planets lay on the inside of a giant sphere that revolved around Earth once a day. So that model became known as the geocentric model. So they kind of, and I think they'll give a kind of a picture of a drawing of what one interpretation of the geocentric model was. Again, big thing with geocentric, Earth was at the very center of our solar system, and everything else was in this giant sphere that rotated around it. Again, big circular ball type shape thing there. Then this idea, which we're going to talk about this in Activity 1 class, this geocentric model stuck around for a very long time actually. Again, there's a lot of political and church being in power type things that really kind of kept this geocentric model going for a very long time. There's actually some other astronomers who came up with these mathematical explanations for why the geocentric model was correct. We're going to take a look at more of those in class with some of these other people, but again, there's some bigger things at play there that kind of kept the geocentric model at the forefront of society there. Then there was a Greek astronomer named Aristarchus, and he developed what was called the heliocentric model with the sun at the center. His model was not accepted by most ancient Greeks because, again, kind of going along with this whole thing that it's just kind of human nature for humans to want to consider themselves at the center of everything. Again, churches and politics kind of being kind of intertwined, and they couldn't really have a lot of proof for as much proof for it at that time because of the lack of technology. But however, even with the heliocentric model not being accepted, the geocentric model that was the one that everyone believed in, it could not explain all of just the simple observations that were made at that time. So they noticed problems explaining like different patterns of orbits and things coming too close and too far away. But again, there was all these mathematical equations that were kind of made up to kind of fit the geocentric model. But again, Aristarchus was like, this just really does not make sense, so I think it should be kind of the heliocentric model, which again, we'll kind of talk about how he got some more support later on. But still, again, he was kind of one of our first ones to propose it, but he really didn't get any support for it as well. Then there was, again, Andreas Solaris. He drew the maps of the geocentric model here on the left. As you can see, Earth is right smack dab in the center there of the geocentric model, and then the heliocentric model in the 1660s. Again, so here we have Earth, or I'm sorry, not Earth, the sun is at the center, again, with everything kind of orbiting around there. And one thing you'll notice that the orbits are kind of very circular in shape, is kind of what they thought the orbits were. And again, maybe some in the heliocentric, they're not quite as circular. You kind of see more oval shape there. So that's going to be kind of an important thing to come into play here. In the early 1500s, so there was a guy, Nicholas Copernicus, that realized that the motions of the planets could be more simply explained if they were revolving around the sun rather than around the Earth. Again, in the activity we're going to do, they're going to talk about how they kind of came up with all these crazy things that I can't remember exactly what the orbits were called, but all of a sudden planets would be going in a perfect orbit, then all of a sudden they would kind of do like a little loop-de-loop within their orbit. So there was all these complicated explanations within the geocentric model, but Copernicus is like, listen, if the sun is at the center, it's going to be much easier to explain why we're seeing what we're seeing. And so then the observations of another really famous guy, Galileo Galilei, and other scientists later proved that the heliocentric model was in fact correct. So again, glad I didn't spoil this at the beginning for you there, but the sun is in fact at the center of our solar system with everything revolving or orbiting around that. Again, Earth was in fact not at the center, so the heliocentric model is the one that was correct. Again, and the reason why we see the motion of the sun, the moon, and the stars is because Earth also spins on its axis as well. So as well as rotating around the sun, which, again, another thing, as we rotate around the sun once, that's a year. As we spin around once on our axis, that's a day. So as Earth rotates, it seems that we are stationary and all the objects in the sky are spinning around us, when however we kind of have two sets of motion going on there. And the northern star appears to circle around the North Star because Earth's axis points toward a spot in the sky close to that star. So again, our axis is also tilted, which hopefully that's not new information to us, but the reason why we kind of have some apparent, again, appear to circle around, again, I did some air quotes there, but you guys can't see my air quotes. The northern stars appear to circle around the North Star because that's just kind of the way our axis is naturally tilted. So that kind of explains some of those observations that those early Greeks were making. So kind of one of the last things to kind of wrap this up, that kind of ties into some of the things we've actually learned earlier on this year, is that gravity and inertia combine to keep the planets in orbit around the sun. So to go along with that heliocentric model, why are the planets actually orbiting around the sun? Again, connection to some physics things here. Johannes Kepler, he discovered that the orbit of a planet around the sun is actually not a circle, because that was kind of one of the early explanations, but it was in the shape of what's called an ellipse. And an ellipse looks like an oval, or kind of a circle that's just kind of been stretched out along one axis. So it's kind of more of an oval shape, I think would probably be the best comparison. And most planets' orbits are nearly circular, and so they're only slightly elliptical. So that was what Kepler said, and again, he called this the ecliptic plane. So the plane that the Earth's orbit is called the ecliptic plane. So again, that we're not necessarily going in perfect circles, but it's this certain area that could be a little bit more stretched out. Then Newton's first law of motion again states that an object in motion continues in a straight line at a constant speed unless acted upon by a force, and this is known as inertia, which hopefully we remember. And he realizes kind of how this applies to planets, is that the sun must be exerting some type of gravitational force on the planets that keeps them in orbit. So again, according to Newton's first law of motion, again, if an object in motion stays in motion, Earth would be flying along in outer space somewhere, but the sun is putting a gravitational force that helps keep us in orbit. So that's it for this video. Let me know if you have any questions.